What's up? I'm Vin, and today I want to go through the 2008 BC Calculus multiple choice calculator section. So let's get started. So at question 76 here, we have the graph of f prime above, and it's the derivative of the function f. And the domain of f is the open interval from 0 to d. And we want to know which of the following statements is true. So we have f is a local minimum at x equals c. So if we go over here, notice that f prime goes from positive to negative here, which would mean we have a local max. So this answer choice is not true because we would have a local max at x equals c. If we go on to choice B, local maximum at x equals b, this is a bit of a trap here because technically this would be a local maximum of f prime, not f. So we just have to be careful here. Once again, they love little traps like this. So if this was a graph of f of x, so if f of x had something like this, then we could say local max. But this is a graph of f prime, so just be careful with choice B. So now we have the graph of f has a point of inflection at a, f of a. But notice here what we have is we have a local minimum. So at x equals a, the first derivative, f prime, now goes from negative to positive. So that means we have a local min. So not a point of inflection here, so we can cross off choice C. And now choice D, we have a point of inflection at b, f of b. This one is true. Reason being is because the second derivative changes from positive to negative at x equals b. We could say f prime goes from increasing to decreasing at x equals b. And if f prime goes from increasing to decreasing, that means that f double prime goes from positive to negative at x equals b. So this tells us we have a point of inflection. This is going to be the answer. Now just to double check here, the graph of f is concave up from c to d. This is not true because from c to d, what we have is f prime is decreasing. So if f prime is decreasing, that means that f double prime is less than 0, which would mean f is concave down, which I'll abbreviate. All right, so that's why choice E is no good, so definitely choice D. Question 77, we have water is pumped out of a lake at the rate R of t equals, and we have this function in cubic meters per minute. And we want to know how much water is pumped from 0 to 5. So for a question like this, we're doing the integral from 0 to 5, and then we have R of t dt. Now the reason why we're doing the integral of the rate is because the rate is measured in cubic meters per minute, and time dt here is measured in minutes. So when you multiply R of t by dt, the cancellation of units happens here, and our final answer would be in cubic meters. So just know the integral of the rate tells you how much. We're not going to just plug into R of t or take a derivative. We do the integral here. So now we just switch over to the calculator to evaluate this integral. So to pull up this integral, we're going to hit Math 9 here, and we're going from 0 to 5. And our integrand is going to be 12 times the square root of. And if you want to make sure you're typing in fractions accurately, you could hit alpha y equals enter to throw in a fraction. And you got t over t plus 1, but we'll just use x. So x over x plus 1. And then we're just going to tack on dx at the end. So we hit enter, and our answer should be 47.193. So now we just go over here, and this is going to match up with choice D. For question 78, we have a graph of the function f, and we want to know for which of the following values of c. So that's what we're looking for. Values of c that make the limit as x approaches c of f of x equal 1. So just know the answer to a limit is the y value. So the first thing I'm going to focus in on is how many locations here do we have a y value of 1. So we have one here, where technically the function is not equal to 1, but it's heading there. The function is equal to 1 here, and also here. So for all three of those points, for how many of them does the limit actually equal 1? Well, so far what we have is c equals negative 2, our limit is equal to 1. Because notice, as we approach negative 2 from the left side and the right side, we're heading to a y value of 1. So far this is good. I'm also going to include in 0 because as we approach 0 from the left side, we're heading to a y value of 1, this green point. And as we approach from the right side, we're also heading to 1. So far this one also works. Now we have to be careful here. It's tempting to say negative 2, 0, and 3, but this is a trap. Because notice, as we approach 3 from the left, our limit is heading to 1, but as we approach 3 from the right, it looks like we're heading to a y value of 1/2. So at this location, the limit as x approaches 3 of f of x, this does not exist, which I'll abbreviate. this limit does not exist. So we just have to be careful. 3 is excluded. So it's really just going to be at -2 and 0, which is going to correspond to choice C. Question 79 highlights a really big idea for the AP test, that you have to show up knowing certain theorems. And when I hear the phrase f is positive, continuous, and decreasing, these three together shout out integral test. So this is the integral test for convergence or divergence. And we're told here that a sub n is equal to f of n. And we're told that the series a sub n converges to k. And we want to know which of the following must be true. There's a very dangerous trap with the integral test. And the trap is that some people will say that the series from n equals 1 to infinity of a sub n is equal to the improper integral of f of x dx. But this is a very dangerous trap, and this is not true. Okay, these are not going to be equal to each other. So if you look right away, notice what we have is that the integral from 1 to infinity of f of x dx equals k. This is the dangerous trap here, that once again, the improper integral is not exactly equal to the series. This just tells you that if the integral converges, the corresponding series is going to converge. It doesn't tell you what it converges to. So what we know is that if the series converges to k, which of the following things must be true? That just tells us that the improper integral is also going to converge. So that tells us for sure that choice D is going to be true. Now, this one here doesn't make sense because the limit of the nth term, if it's equal to k and k is non-zero, that would tell you that the series diverges, not that it converges. From 1 to n, we don't know what the value of n is here, so this is just sort of meaningless for us. And this wouldn't make sense because if the improper integral diverges, that would mean that the series from n equals 1 to infinity of a sub n would also diverge. So choice C doesn't work because we already know the series converges, so definitely choice D. For question 80, we have the derivative f prime, and we want to know how many points of inflection does f have on the open interval from -2 to 2. So for a question like this, please make sure you do everything in the calculator. Don't waste time finding the second derivative by hand. So let's switch over to the calculator view. So for a question like this, we want to find the points of inflection, and we were given the derivative. The derivative was x squared, and then we had cosine of x squared attached right next to it. Now, we have to be very careful. This is f prime. If you want to find points of inflection, you want to look at the second derivative, so we would take the derivative of f prime. But we're in the calculator section, so we're not going to do product rule, chain rule. That would just be a waste of time. We're going to do the derivative of y1. And now you could rewrite this whole thing all over again, or you could press vars, you go to the right, and you go to function y1, and that's going to tell the calculator to write this over here. And then we're going to do this for x equals x. So this just is a nice way of using the calculator to take the derivative. Now I'm going to turn the graph off, but the problem is that if I go and press graph here, this picture is very difficult to look at. So remember what they told us, that we're looking on the open interval from -2 to 2. So that's what we're going to do here, is just switch over from -2 to 2. And we press graph again. Now, if this picture doesn't do it justice, what you could do is you could mess with the window settings even more, but I think it's clear to see here that if this is a graph of the second derivative from -2 to 2, a point of inflection occurs when the second derivative changes sign. So we're looking for when the graph goes through the x-axis. So notice it happens here at 1, 2, 3, 4, 5 locations. So we're going to have 5 points of inflection from -2 to 2. So we're going with choice E. 81 was a bit of a painful question, so we'll just set this up very carefully. So we're told here that A is less than C, which is less than B. So if I think of the entire interval here from A to B, C is somewhere between there. And just know from A to C, this represents the part. This represents another part. And we're going to use the concept here that the whole is equal to the sum of its parts. So now we're going to look at what information we were told here. So we have the integral from a to b of f of x dx is equal to p. So just know this piece here represents a whole representation of the interval from a to b. So this is like the whole piece. And then from c to b, f of x dx equals q. Notice this is equal to a part. Okay, so from c to b is just one part. And then we're given more information here. The integral from a to b of g of x dx is equal to r. So this represents the whole interval from a to b, and then the integral from c to b of g of x dx, that represents another part. So now the concept is that we're looking for, in this question, the integral from a to c, which is the other part. So what I think of in my head for a question like this is I think that the interval from a to c plus the interval from C to B, that's going to give you the interval from A to B. So if I want to come up with the integral from A to C, I have to do the whole interval A to B minus the part from C to B like this. So that's the idea we're going to use. So what we're going to have here is that the integral from A to C of f of x dx is equal to, so that's A to C is one part, is equal to the integral from A to B of f of x dx minus the part, and remember we're solving for the part A to C, so we would subtract the other part from C to B. So once again, this representation here, this is the whole area, this is one part, and this is the other part. So the whole is equal to the sum of its parts, so if we want to find one part, we do the whole thing minus the other part. So now we just plug in the integral from A to B of f of x dx is equal to p, and we'd have minus the integral from C to B of f of x dx is q. So we have this. And now the next thing we could write is that the integral from A to C of g of x dx, same exact concept, is equal to the entire area from A to B of g of x dx minus the partial area from C to B of g of x dx. And now this, we just plug in the givens again. So the integral from A to B of g of x is r, minus the integral from C to B of g of x is s. So now, to answer this question, we're just going to do f of x minus g of x from A to C. So we're going to take these two answers here. We're going to do this thing minus this thing here. So we'll just do that now. This is going to work out to, we're going to have p minus q minus parentheses r minus s. These parentheses are very important because it's going to influence the answer. We have p minus q minus r, but then we're going to have a plus s at the end. So p minus q minus r plus s is going to match up with choice B. Question 82, we have to know all of our convergence and divergence tests. So this one here, when I read a sub n, that series diverges, and a sub n, b sub n, those sequences are greater than or equal to 0, but b sub n is greater than or equal to a sub n. This is shouting out direct comparison test. So the way the direct comparison test works for divergence is that when you want to show that a series diverges, you have to find something smaller that diverges, and that means everything bigger than that series is going to diverge as well. So the fact that a sub n, this series diverges, what that tells us is that everything bigger would diverge as well. So the series b sub n is automatically going to be greater than or equal to this series because of this inequality here. So once again, if the smaller series diverges, everything bigger is going to diverge as well. So this diverges as well by the direct comparison test, and that's going to match up with choice E. If this question were flipped and they wanted to show that something converges, then we would start with the idea that if a sub n converges, let's say they switch the question around to this, then they would have to tell you something different. They would have to tell you that a sub n is greater than or equal to b sub n, which is greater than or equal to 0. And then the idea by the direct comparison test is that when you want to show that a series converges, if a big series converges, everything smaller is going to converge as well. So this would be, if they flipped it around, how we would show that b sub n is a convergent series, but this is the information they would have to give us if it was going to be choice D, but it's not going to be choice D. We're going with choice E here. Now, question 83 is a nice question because we could do all of it in the calculator. Now, the first thing I would do is type both functions in the y equals section. So we have x to the third, and after this we have minus 8x squared, and then we've got plus 18x minus 5. So this is a lot to type in, but then after this we've got x plus 5 is our second equation. And for this question here, we want to find the area between the curves. So notice the picture doesn't really tell us much, so I always hit zoom 6 to put it back to normal. And what it looks like is most of the action is happening in quadrant 1. So I would go ahead and switch the window from 0 to 10, and our y minimum could be 0, and we could switch our y maximum to, let's say, 20. That way we just get a better picture of what's going on. And here, I don't need all of that stuff in the x direction, so maybe I'll switch this out to like x equals 6 is our max. So you see, now we have a nice idea of what's happening. Now there's two ways to do this question. We want to find the area between the curves. That means we're finding the area of this space and this space here. But a nice little trick that we could go with here, it looks like this thing intersects at 1, 2, and about 5. So I would just go to the table to double check this. If we look at x equals 1, see they have matching y values, so that's our first intersection point. X equals 2, we have matching y values, and x equals 5, we have matching y values. If you had to, let's say it intersected at a decimal, you could always hit second trace 5. And then you go before the intersection point, you hit enter. You scroll after the intersection point, hit enter a second time, and then a third time, and it tells you the point of intersection. So normally what I would do if I didn't have a calculator is set up two integrals from 1 to 2 and from 2 to 5. But the beauty of the calculator section is that you could use absolute value, and then it doesn't matter that these functions reverse roles. Like the curve in blue is the top function, the red line is the bottom function, and then in the second region, the red line is the top and the blue curve is the bottom. The absolute value function will fix all of that for us. So we could just do the integral from 1 to 5 all in one shot, but then we have to remember to just do math, absolute value, and I'm going to do y1 minus y2. It doesn't matter if I do y1 minus y2 or if I do y2 minus y1, because the absolute value is going to fix the order in the event that the top function and bottom function change. So once again, the absolute value, the beauty of it is that if the order gets mixed up, the absolute value is going to correct it. So if I did blue minus red here, it would be positive, but if I did blue minus red here, it would be negative, but the absolute value is going to correct that. So you don't really have to pay attention to any order, and this would give you this answer. But let's say I didn't use it this way. Remember what we said is that the first region is from 1 to 2, and then the second region is from 2 to 5. So notice in the first region, the blue, y1 is on top. So if I wanted to do this another way, I could do math 9 from 1 to 2. And remember what we said, the blue one, y1 is on top. So I would do vars function y1 minus vars function y2 dx. And then I would have the integral from 2 to 5. And then they reverse roles. y2 is top and y1 is bottom. So I would do this all over again, but I would do y2 minus y1. So this is the more painful way of doing this, but it's going to give us the same answer. So we press enter here. Either way, our answer is going to be 11.833. So we're going to go with choice B. Question 84, we have to show up to the AP test knowing certain formulas. And for this one, we have to know the formula for a Taylor polynomial. And in this case, we have a third degree Taylor polynomial, and it's for f of x about the center x equals 3. So we have to know how to just set these things up. So this is going to be equal to f of 3 plus f prime of 3 x minus 3 to the first over 1 factorial, and then we'll have plus the second derivative at 3 times x minus 3 squared over 2 factorial, and then we'll have plus f triple prime of 3 x minus 3 to the third over 3 factorial. So for something like this, what we have to do is they told us f of 3, f prime, f double, f triple. We're just going to make a substitution for these four things, and then we just have to match it to the correct answer. So we'll go ahead and do that now. Our third degree Taylor polynomial, f of 3 is equal to 2. So that's the first thing going here. So we have 2 plus, and then f prime of 3 is negative 1. So I'm going to have minus 1 times x minus 3, which I could just write like this. And then our next coefficient, f double prime of 3, is equal to 6. So that's going to go here. So I'd have 6, and I'll just do that on the side. 6 divided by 2 factorial is 2 times 1, is going to give us a coefficient of 3. So this is going to be plus 3 times x minus 3 squared. And then the next one here, we have f triple prime of 3 is 12. So that's going to go here. But I could simplify that on the side as well. I'm going to be doing 12 over 3 factorial, which is 3 times 2 times 1. And 12 divided by 6 is 2. So this is going to give us plus 2 times x minus 3 to the third power. So now we just have to match this to the answer key. And this looks like it's going to match up with choice A. Question 85 is mostly calculator work, but we have a particle moving on the x-axis and we have a velocity function here from negative 3 to 3, and the variable is t here. And we want to know how many times does the particle change direction as t increases from negative 3 to 3. So a particle changes direction when velocity changes signs. And it doesn't matter if velocity changes signs from positive to negative or negative to positive. All we need is a sign change to occur. So for this one, we're going to use the calculator to graph this function from -3 to 3 and see how many times it goes through the t-axis. So we're going to go to the y equals here, and we're going to clear out what we had from before. And for this one here, we have 3t to the fourth, but we're going to use x. So we have 3x to the fourth. And then we've got minus 11t squared, but once again, we're using x. And then we got plus 9t, or 9x, and then minus 2. And the window, remember, we're going from -3 to 3. So we're going to switch the x minimum to -3 and the x maximum to +3. Now, what we're looking for here is the sign change. So I could get really close to the x-axis, even though in the question we're calling it the t-axis, but that's going to be interchangeable here because we just have one equation. So we're going to graph this, and notice we have one sign change here. At this location, we don't have a sign change. What this looks like is that what we have is we have this curve is tangent to the t-axis at this location, but not going through. But it does go through here, so we're going to only have two changes of direction using these 2 points here. So the answer to 85 is going to be choice C. Question 86 is a nice question, and the hard part is translating all this stuff. So when they say this here, we have the graph of y equals f of x. This line is a little confusing. The slope at any point x, y is twice the value of x. Well, this phrase, the slope at any point, is known as the derivative. So that tells us that f prime of x is equal to twice the value of x. So that's 2x. And then they're telling us if f of 2 is equal to 3, what is the value of f of 3? Well, if f prime of x is equal to 2x, we could just do the antiderivative of 2x to find f of x. So the antiderivative of 2x, we could do that on the side, is going to be x squared plus c. So we're just using the Powell rule here. So we have x squared plus c. But now we could use the initial condition to solve for the value of c. F of 2 is equal to 3, but f of 2 is equal to 2 squared plus c, which is going to be equal to 3. And that tells us if 4 plus c is equal to 3, c is equal to -1. So the particular solution here, f of x, is equal to x squared minus 1. So if we want to find f of 3 is equal to 3 squared minus 1, and 9 minus 1 is equal to 8. So this is going to be choice C. For question 87, we have an object traveling in a straight line, and we have the position function x of t, and we have initial position here, and we have a velocity function telling us how fast the object and direction that it's moving, and we want to know the position of the object at t equals 3. Now, for a question like this, if you want to find the position at t equals 3, if you know your formulas, you'll show up and say, all right, x of 0 plus the integral from 0 to 3 of v of t dt. So if you know this, then great. But let's say you were to forget something like this. The big idea for this question is if you know the fundamental theorem of calculus part 1, if you were to forget this direct setup, you could set up the integral from 0 to 3 of v of t dt, and then by the fundamental theorem of calculus, we do the antiderivative of velocity, and the antiderivative of velocity is position. So we would have the antiderivative is x of t, and then we plug in the upper limit, we plug in the lower limit, and we subtract those two. And then you could see here that if I want to solve for x of 3, I just have to add x of 0 to both sides. And that's where, if we do plus x of 0 on the left side as well, this is where this equation is coming from. So now the rest is calculator work. Please, for questions like this, don't try to do any antiderivatives by hand. Just make sure you're doing Math 9 to do antiderivatives. So we're going to switch over to the calculator view. The only thing is we're going to swap out x of 0 we were told is equal to 2. So we're going to be evaluating 2 plus the integral from 0 to 3 of v of t dt, where v of t is equal to this cube root 1 plus t squared. So now let's go ahead and type this in. So once again, what we have is we have 2 plus, and we're going Math 9, and our integral is going from 0 to 3. And then our integrand, we have the cube root. We could press Math, and cube root is number 4. So we have the cube root of 1 plus t squared. But we're just going to go ahead and use x squared. And then we just punch in, we have dx here. And now our solution is going to be 6.512. So we're going with choice D. Now 88 is a really good question. You have to read very carefully here to be able to get the correct answer choice. So we're told here we have a continuous function f. And f is positive and decreasing. So we have g is the function g of x equals this area function here. We want to know which of the following could be a table of values for g of x. So one thing I do immediately when I see g of x equals this type of area function is I go ahead and I find the derivative. G prime of x would be equal to f of x. If we take the derivative of this area function, we're using the fundamental theorem of calculus part 2. And if g prime is equal to f, that means that g double prime of x is equal to f prime of x. So now I'm going to reread this question again. And note they said f is positive. And if f is positive, what that means is that g prime is positive. So we have a few things here. F is positive tells us that g prime is positive. And if f is decreasing means that f prime is less than 0. And if f prime is less than 0, remember f prime is equal to g double prime. This means that g double prime is less than 0, which means g is concave down, which I'll abbreviate. So if g is concave down, that tells us if we were to look at a picture of it, it would be in this frowning shape here. And combine all of this. G prime is positive. G prime is positive means that g is increasing. So we have all this information together. G is concave down. G is increasing. And then how does that help us here? Well, if g is increasing and concave down, that means it's going to increase, but by smaller and smaller amounts, because on a concave down curve, the slopes are getting smaller and smaller. So g is increasing, but what we're looking for is that g is increasing by smaller amounts each time. So by smaller amounts. So once we look for that, that's going to give us the answer right away. So looking at this, some answer choices we could get rid of right away. Notice g is decreasing here, so c is out. If we look here, choice D, g is decreasing, this is out. And this one here, g decreases then increases, but g should just be increasing here. So that eliminates it down to choices A and B. So for this one, you would look and say, all right, g is increasing, but notice from 1 to 2, g goes up plus 2, and then it goes up plus 1. But for choice B, g of x goes up plus 2 from 1 to 2, and then the y value here goes up plus 3. But remember what we said, g has to be increasing by smaller amounts. So notice this function is increasing by 2 and then by 1. So this function is increasing by smaller amounts, so it's definitely going to be choice A. That's why choice B is out, because this function is increasing by increasing amounts. So this would represent something concave up. Question 89 I really like, because if you know your theorems, this question is really easy. But if you don't know your theorems, this is a very confusing question. So we have f is continuous from -2 to 2, and we have f of -2 equals f of 2 equals 0. And then we're told this here, there is no value c where c is between -2 and 2, where the derivative is equal to 0. So this language is shouting out two theorems. It's shouting out the mean value theorem, but it's also shouting out Rolle's theorem. Rolle's theorem is like a little subcase of mean value theorem where your endpoints are equal. So these are the two that it's shouting out, but just know for either of these, the condition is that f is continuous. So f has to be continuous on the closed interval, but it also has to be differentiable. It has to be differentiable on the open interval. So when we look at this here, notice what they're telling us. They're telling us that f is continuous, but the conclusion is not following. Okay, so the conclusion fails. So if the conclusion fails, that means something in this has to fall apart. But since they told us f is definitely continuous from -2 to 2, this condition is satisfied. So that means this is the one that has to fail. So how does this fail? How is f not differentiable from -2 to 2? Well, this would match up with choice E, that for some value k between -2 and 2, the derivative is not going to exist. Because once again, continuity is already established. We were told f is continuous on the closed interval, which means at some point the function can't be differentiable on the open interval, because once again, the conclusion fails for MVT, which means one of these has to fail. So this is the one that has to fail, and it's going to match up with choice E. Question 90 is just be awesome at chain rules. So if you have h of x equals f of g of x, we could say h prime of x is equal to f prime of g of x times g prime of x. Just remember the chain rule. We do the derivative of the outside, we keep the inside the same, and then we multiply by the derivative of the inside. So h prime of 2 is going to be equal to f prime g of 2 times g prime of 2. So now we just go looking in the table. G of 2 is going to be negative 1. So this is equal to f prime of negative 1 times g prime of 2. So we go to g prime, and at 2 it's equal to 2. And then we look for f prime negative 1. F prime is here, and at negative 1 f prime is equal to 3. So this is equal to 3 times 2, which is going to be equal to 6. So 90 should be choice D. Question 91, we're going to use the first derivative test because we have f is the function given by this area function, and we're on the interval from 1/3 to 1. And we want to know at which value of x does f attain a relative maximum. Now, the moment you hear relative maximum, you should think f prime is going to change from positive to negative. So this is what we're looking for. Where does f prime change from positive to negative? So first up, we have to know how do we find f prime of x. And f prime of x, if we take the derivative of both sides, we're using FTC part 2. So this is by FTC, the fundamental theorem of calculus part 2. So since we have a constant up to x, the derivative and the integral are going to cancel, giving us cosine of, and we just replace t with x, and we have 1 over x squared. So from this step here, we could switch over to the calculator view and look at the graph to see where does the graph change from positive to negative on this interval. So we'll switch over to the y equals here, and we're going to type in our function. We've got cosine of 1 divided by x squared. And for this one here, we're switching the window over to, we're going from x minimum of 1/3 to a maximum of 1. And we're looking for the sign change, so the window from -3 to 3 should be fine here because it's going to show us the roots very clearly. Now, we were looking for a relative maximum, and a relative maximum is when the derivative changes from positive to negative. So notice here, this would be a relative minimum because we're going from under the x-axis to over. So we're changing from negative to positive at this location. So this is not one we want. We also don't want this one because at this location we're changing from negative to positive. But this is the one we want because the graph changes from positive to negative at this space. So we're going to do second trace 0 to trace the root. And we're going to go backwards. We're just tracing the second root because that's the sign change that we want from positive to negative. So this is a good location because we're above, we're in the positive, and then we scroll to the right until we get into the negative. Hit enter 2 more times, and then our solution is going to be x equals 0.461 if we round to the thousands place. So we looked through the answer key, it was only one solution, and it was x equals 0.461, so we're going with choice D. So for question 92, we just have to use the chain rule again. We have the graph of f and g, and we have lines tangent to the graph of g at -3 and 1. And we're told b of x is equal to g of f of x. We want to find b prime of -3. So b prime of x, we're going to use the chain rule again, is derivative of the outside is g prime. We keep f of x the same on the inside, and then we multiply by the derivative of the inside, which is f prime of x. So what we're looking for here, b prime of -3 is going to be equal to g prime of f of -3 times, and then we'd have f prime of -3. So this is what we're looking for here. We'll just make this a little bit neater. So we have times f prime of -3. So now we just have to go looking at the graph. So f of -3, here's the graph of f. -1, 2, 3. F of -3 is equal to 1. So far we have this is equal to g prime of 1 times f prime of -3. So now we could just go looking for g prime of 1 is the slope of the graph of g at x equals 1. And notice they included a tangent line for us. Now, it would have been really nice if this wound up directly on the corner here, but notice we're going down 1 over 2. And if we're going down 1 over 2, that means we have a slope of -1/2. So g prime of 1 is going to be equal to -1/2. And then f prime of -3, if we go here, this very clearly has a slope of 1/3 because we're going up 1 to the right 3. So we go up 1 and over 3. So now we have a slope of 1/3, and when we multiply -1/2 by 1/3, we're going to get -1/6, which is going to be choice B. All right, well, this is going to wrap up this video. I appreciate you sticking it out to the end, and best of luck on your AP Calc test.